Welcome to Meaningful Magical Math. Today I'd like to show you how to solve word problems using a strategy called C.U.B.E.S. And to do so, we're going to use our at-home instruction book on page 99. So if you'd like to pause the video and go get your at-home instruction book and turn to page 99, you can work right along with me. On page 99, we have problem number 3 at the top. So we're going to read that. Petra walked 9 miles the first week of this month, twice that far the second week, and 6 miles the third week. How many miles did Petra walk altogether? Well, C.U.B.E.S starts with a C, and that stands for circling the numbers in your problem. And I see a 9 and I see a 6 for sure. Sometimes numbers are written in words. I see something that looks like a number here. I know that first isn't really a number like 9 or 6. It's an ordinal number, but maybe I'll need it, maybe I won't. I also see twice. That's also a number in words, except this one is actually a multiplicative number. Twice is 2 times. I see the word second, which reminds me of first. Maybe I won't need it, maybe I will. I'm going to make note of it. And I see third. Maybe I'll need it, maybe I won't. I don't see any other numbers in my problem. The next letter of my strategy is U. Underline the question, or the problem you're going to solve. How many miles did Petra walk altogether? So I've underlined that. The B stands for box keywords. Now I notice that we're going to have to find how many she walked altogether. That sounds like to me that I'm going to have to add. Sometimes, though, I might even have to multiply to find something altogether. So I'm not sure yet what I'm going to have to do. I just know that keyword reminds me of that. And I think that's just about all the things here in this problem that are key words for me. I know I'm going to have to find the number of miles, so that's important. That's a unit that I'm doing, that I'm going to have to solve for. Then I need to think about eliminating. The E stands for eliminating extra information. Now in this problem, I don't really see anything extra. I believe I'm going to need to know how many miles she walked the first week, how many miles she walked the second week, and how many miles she walked the third week in order to find out how many miles she walked altogether. If my problem said something about Petra walking 9 miles the first week, and then she went to the ice cream store and got an ice cream cone and met her friend there and had a great time, all that stuff about the ice cream store and meeting her friend and having a great time would be extra information. But in this problem, I don't see anything extra. And in very few problems will I find extra information that will try to confuse me. Then let's think about our S. S stands for solve the problem, so we're ready to solve. So I think I'm going to make a table over here because I think a table will be a good way to organize my thinking. I know that we're talking about weeks, a first week, a second week, and a third week. And we know we're also talking about the number of miles that Petra walked. So on the first week, I think I know why we've said first here. I think this isn't a number I'm going to need. It's just telling me, it's an adjective describing what week I'm talking about. So the first week she walked 9 miles. So the first really wasn't a number I had to compute. It's just an adjective for my problem. And the second week, there I go again. There's another adjective to describe the week. The second week, she walked twice the first week. So that's 2 times 9, which is 18. And then the third week, again, that's another adjective, that third week. I really didn't need these numbers to compute. I just know that they have something to do with the week I'm talking about. So the third week, she walked 6 miles. How many miles did she walk altogether? Well, I did have to do some multiplication here, but in order to find out how many miles she's walked altogether, I'm going to have to add these together. So that's 9 and 18, being sure to place my 18 and 9 in correct place value order, and 6. So I'm going to add these together. Let's see if I can organize this pretty well. Well, 9 plus 8 I know is 17, and I know 17 plus 6 is 23. So I'm going to carry the 2. 2 plus 1 is 3. So she's walked 33 miles altogether. And I can abbreviate miles for MI altogether. Now let's keep trying this strategy, cubes, for another problem, number 4. Let's move on to number 4 and take a look at that problem. Miss Ruiz planted 14 flowers in 3 pots. She planted 4 flowers in the blue pot and split the rest equally between the red pots. Write and solve an equation to find the number of flowers Miss Ruiz planted in each of the 2 red pots. Okay, again, let's use cubes. C stands for the number, or the circling the letter, circle the numbers. 14, I see 3, I see 14, I see 1, I see 2, I see 2 here. All right, I've got all those numbers circled. We're going to have to decide which numbers I need, but at least they're brought to my attention. Do I see any other words that represent numbers? No. The next one, U. The next part of my strategy is U, underline my question. Well, I don't see any questions here, but I know I'm going to have to solve to find the number of flowers Miss Ruiz planted in each of the 2 red pots. Oh, these 2 red pots go with these 2 red pots. So it's not 2 different sets of red pots. It's just that they've repeated that, 2 red pots. So that's my underlined problem that I have to solve. Now let's look at the B. B means box keywords. So I'm going to have to find the number she's planted in each of the 2 red pots. So each could mean that I'm going to subtract to see, because I did have a total already, and I know I'm going to have to figure out how many go in each. Each often, though, means divide, especially if I see the keywords equally and split. Those are keywords that remind me that we're going to have to divide here, to divide up a total number into equal groups, or equal pots in this case. And then my E is eliminate any extra information. Once again, I don't see any extra information. If they started telling me what kinds of flowers they were, that would be some wonderful information to know, but not helpful in my problem. So I don't have any extra information here. And the S is to solve the problem. So we're ready to solve the problem. So how many flowers did Miss Ruiz plant in each of the 2 red pots? Well, how many did we start with? We started with 14 flowers. And then she planted 4 flowers already. So that means I'm going to have to take those 4 flowers she planted and subtract those 4 from the number she started with. That means I have 10 flowers left. And then she splits that remaining number equally between 2 red pots. Splitting 10 equally among 2 red pots is dividing by 2. So 10 divided by 2 is 5. So that's 5 flowers in each pot. So let's see, what would my equation look like? I've solved this already, so 5 flowers in each red pot is my answer. But what is my equation going to look like? So down here on my line, I'm going to write down 14 because that was the number I started with. And I had to subtract 4. Remember up here? And when I figured out that answer, 10, I'll put that in parentheses because I know those 2 numbers must be worked together. So 14 minus 4, this problem must be worked together. Once I found out that was 10, then I took my answer 10 and divided that by 2. And that gave me the number of flowers, I'll call that F, in each of the 2 red pots. And of course, we learned that F equals 5 flowers in each red pot. Okay, there are 2 examples I've shown you today of how you can use the C.U.B.E.S strategy to solve word problems. In the meantime, I'll see you next time on Meaningful Magical Math.